Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Mwaka. I am your instructor. Today, we will be performing a full structural design for this building, as you can see it here, and we will be using Protastructure as our design software. Okay, looking at this right now, you can see that we are using a real life project for the design of this structural building. As you can see it here, this is already a construction drawing that is done by October 2022. So this is a job that we got from our client, although is my auntie, as you can see it here, auntie's building. So it's actually my auntie's building. So we are trying to perform a full structural design for this building. And as you know, all our designs in this Ekidel is always based on a real life project, because I believe that it is on real life project that you can teach anyone that you want to teach very well. Okay, so right now we will be performing a structural design for this one-story building. Actually, it's not really a one-story building, because it's like it's just having a paint floor. As you can see, the first floor plan here is just the master's room that is up. But since it has since it has a slab decking, that's now required a structural design for just this area, as you can see it here. So we are going to perform a full design for just this area, and we will be using Protastructure to perform this structural design. And also I will also put this CAD file on the link down below, so that you can download that and then use it for your practice. Although you can just give us a support, so that we can also use to manage Ekidel. Okay, so right now, to begin your design, before you can export your plan to Protastructure and begin your structural modeling and then designing, you have to copy out the both plans which you are performing the design for. So I'm going to copy out these two plans right now. So once you get your plan from your client, the first thing to do is to copy out the first floor plan and the second is to copy out the first floor plan and the is to copy out the ground floor plan and the first floor plan. Sorry. So right now, you just copy out the ground floor plan and the first floor plan, which we have just done just here right now. Now, once you have copied them out right now, I always advise, as a structural engineer, you have to remove all these unnecessary items which are found on the plan, which are all these bed symbols, because we don't deal with all these symbols. All we do with is the block walls and other important features. So right now, I'll just remove all this right now, remove all these features which are not necessary. Okay, so you can see what I'm doing right now. So you just do that right now on your own also. So like I said before, I will attach the CAD file for this full drawing on the link down below, so that in case you want to use it for your practice, it will be very easy for you to flow with me. Okay, so we will be performing this full design using Protastructure, and then we will now also use a stone bridge structural detailing template to perform the full structural detailing after we are done with the design in Protastructure. Then we will also use the CAMSUIT Civil software to now perform this slab detailing of this open well, as you can see it here. Okay, so right now I'll just remove all this right now, and then remove this dimension which is unnecessary. Okay, and remove this also. Okay, and I'll just remove all these dimensions here, because I want my plan to be very clear, so that I can be able to see where I can place my columns and how I'm going to run my panels. Okay, so this is what you're meant to do once you receive your structural plan, and you also perform your GA on your ground floor and not on your first floor. And GA simply means general arrangement drawing, which simply means column position. Now, once you get your plan, also the first thing to do also is to know the kind of block wall thickness that was used. So right now, if we check this right now, you can see that this block wall is 150 millimeter, which simply means 6 inches block. So right now you can see that all the block are being drawn by 150 millimeter size, as you can see there, which is 6 inches. So in this case right now, you can see that also from the site plan, as you can see it here, I think, yeah, the site or the land is very small. I think it's a half plot, so they are trying to manage their land to be able to achieve all this building inside this plan, which they have already placed the building. So you can see there, so they are already restricted with space. So I think that's why they use 150 millimeter for the size of the block wall. Okay, so with that, right now we will also obey them by using our column size to be 150 millimeter. But I will tell you what to do when your column size is 150 millimeter, because the minimum column size you're meant to use for an upstairs is 225 by 225 millimeter. But what happens when you are being restricted in this kind of way? I'll show you that right now. Okay, so right now the first thing to do, once you've done removing all the elements, as you can see what I've done there, which are the bed, chairs, and all that, what you now do is to now go ahead right now and create two layers, because for the software Protastructure to be able to understand this plan, you have to create two layers, and that two layers are called grid and columns. So we will now go here right now and create those two layers right now, and click on this place called um, new, and then change the name of that first layer to grid, and then come here and choose a color. You can choose any kind of color. Okay, they say grid is already found in this layer. So let me go and check what that name is. Let me just check if there's any name called grid. Okay, there is. Let me see, grid. If there is okay, there's a name called grid here already. So I'll just rename this to any kind of name, and then go ahead and create my new grid called new layer called grid. Okay, I will now choose a color which I prefer. I always like to use yellow. Yellow is always it's always visible for me. Then I will now go, once I choose that, put the name and the color if you want to use color. Then I go again and create another one again, and I call it column. So only these two grid that you're going to create for the software Protastructure to be able to know your building plan. Okay, so right now I also choose my thickness for the line width for my column to be 0.4, 0.5. Okay, that's okay, 0.5. And then I will now go here and now click on this place. Good. Okay, so right now you can now see that if you check on our layer drop down right now, you can see that we have that layer called column, and we also have a layer also called grid, as you can see it here. So right now, to now perform our general alignment drawing, which is the first thing you need to do before you can export your plan to Protastructure, the first thing to do is to now go ahead and click on grid to find grid, and then place your grid. Now you have to start placing your grid on the midline of all the walls. Okay, so right now I will now go to type XL, which means construction line. So I'll type XL and press enter, and type V and press enter. I'll now go here and locate the midpoint of this wall, as you can see it here, to confirm that if that's really a midpoint. You cannot check if, since this is 150 wall, that means the midpoint should give me 75. So this is now okay, as you can see it here. So we will now go ahead again, XL, which means construction line, or just click on this place, construction line here, and then type V again. So I will place all my vertical grid lines on all the walls. Now, since all my walls are having the same size, I'll just come here, copy this one right now using CO, and then copy from here, from the base point here, and start placing on all that base points directly at that point. As you can see it here, this makes it faster for you to place your grid line immediately. That's if all your walls are of the same size. So you can now see that we have already placed this also. Okay, now we are almost done placing all our okay, this one all here also, and then we are also all done placing all our vertical grid lines. Can see it here. Now we will now enter horizontal one. Now XL again and press H for horizontal, enter, and then begin to place. Okay, there is something we call mentorship program on Ekidel. So if maybe you want to be trained specially on the design of buildings using Protastructure or other softwares, you can just hit us up on our WhatsApp link, or you can go to our about page and hit us up, or you can check also on this video description where you see join our mentorship program, where we will train you on live project online and end screen, where you will now be the one performing the design, and just we will now be directing you on what to do, and sometimes also we will also teach you on that. Okay, so right now you can now see, then we'll also place one here also, so XL horizontal for this one, and place this also. Okay, like I said before, this is a live project, and as you know, in Ekidel here, we normally do live project because we believe that that is only way where people can understand. So we don't just pick up a plan and begin to just do a practice. No, we want to train future engineers because we have seen that a lot of good engineers are not really available again because people don't have time again to teach these young engineers what to do and what not to do. So because of that, we have already given our life to teach these good coming engineers so that when I enter a hotel in the next 50 years or 20 years, I'll just keep my mind relaxed knowing that this hotel was being designed by a good engineer. Okay, so right now you can see once you're done placing all your grid, as you can see here right now, you will now go and create just a small rectangle here to just trim off all this excessive grid line, because since this line was done with a construction line, you can see that it has no end. So you can now trim it off by clicking on this place right now and trim off this and trim off this. The whole idea of creating this one here right now is just to trim off these excessive lines, as you can see it here. Then I'll now go and delete this right now. Okay, so right now, once you have done this right now, you can see that we have placed all our grid lines. This is called a GA drawing. Okay, next to do right now is to now begin to place our columns. So you go here right now and go and click activate column layer. As you can see what I'm doing right now, here must be by layer, layer, and layer. Okay, so right now, before you start placing your column right now, you can see that we have two big columns here. So what I'll do right now is to go and look at what that is. I'll go and look at the elevation, as you can see it here. Okay, this is elevation, and from what I'm seeing here right now, I think what happened here is that there is a column here, but I'm not going to use the biggest size of this column. I'll just put a column at the middle so that they can use block wall to now finish it up. So I'll just go here right now and place on our GA drawing and place a column directly at the center, or two columns here and here, because by placing this size of column, it might cost them a lot of money to cast. Okay, this is 225 by, let me see the size, by, oh, okay, it's not that big, so I can use that and place a full column. So to place a column right now, you have to use a rectangular icon and not a line icon. If you use a line icon to create your columns this way, Protastructure will not be able to understand that that is a column, and all your work done here will be wasted because this thing will not going to appear as column in Protastructure. So always use rectangle icon or rectangle icon. Actually, I really advise that rectangle icon to create your column. So since this column has already a fixed size of 225 by 450, I'll just click here right now, go here, click on that point, and then click at this place. So right now we have established our first column, which came with a plan as for the beauty of the building. So as you can see it here from the elevation, it gives beauty to this plan. So this is the main column that gives beauty to the plan, and we have obeyed that by giving them the same column. So now we will now have to now begin to place our internal columns. Now when placing your internal columns right now, I'll just click again on this place again, and then click on this place and on this place. Now looking at this right now, if you bring out this column right now and you say what is the size of this column, if you dimension it right now, you can see that this column is given us size of 150 by 150, which is very small for a structural design building. As you can see it here, it's very small. So what do you do when you have a wall size of 150, and as you know, you have to meet up the required area of column for structural design? And to do that right now, so once you have a block wall of 150 size, what you have to do is that you have to make your column size to be at least 150 by 450 minimum size to use. The reason why I say that is because if you check a standard minimum size of column to be used, which is 90 by 90 column, which is 225 by 225. So if I do that right now in meters, 0.225 multiplied by 0.225. This is the required minimum area to be used for a reinforced concrete column. As you can see it here, 0.051 approximately. So if you check 0.15 right now multiplied by 0.45 to check if it will equate this one here, the value that we got here, 0.0151, sorry, you can see that we have 0.067. So this is the minimum, this is the minimum area of column to use if you're using 225 by 225 block wall and also size of column. Now when your block wall becomes 150, I would say you should use minimum 0.15, which is 150 by 450 size of column. That will be safer because I can see that it has already surpassed the minimum. Most of people will go and use 0.15 by 300. Let's check out that right now. 0.15, 0.15 by 300, 0.3. That gives us below you can see that this one gives us 0.05, but this is giving us below. So I always advise you use 450. Most people still go ahead to go and use 0.15 times 0.35, which is 150 by 350. So let's see that also, which might give you a bit. You can see, okay, that this gives us 0.05, but I don't really advise this. I always advise you use 0. That's 150 times by 450 size of column, which is more safer. Okay, so right now I'll just go and delete this right now because this doesn't meet up our requirements for the size of area to be used for the column. So I'll go here right now and click at the rectangle, click any point here and type 150 as my width of column and by 450 and enter. I will now go here right now, click at this place, move on this point and then come here to place it directly in this place right now. So you can now see that this is now okay, as you can see here right now. So we can use this right now. If we check this here right now, if you check this size of column that we have done right now, this is 450, as you can see it here, by 225, as you can see it here. So like I said before, we train here, in Ekidel here, we train real life projects. So the reason why I'm explaining all this is because I'm training you guys real life projects. While most other people will just go ahead and start inserting columns without telling you the rules. Okay, so right now, knowing that our building is not fully a duplex or an upstairs, it's just some portion which is an upstairs, as you can see the first floor here. So we will just go ahead right now and form something and to know the particular area that will have this upstairs. So just form something like this, something of this nature, to get the direct point where we have that particular upstairs. Okay, so I'll just form something like this right now and then make this thicker, and then you can see that right now I'll now copy this from here. I'll copy this right now as a base point, copy here from a base point, and then go and check it out here as the base point here. Okay, so this is the place where we are going to perform our structural design alone, as you can see it here. So this is the place where we're going to put our critical column sizes to be able to withstand this upper floor, as you can see it here. So we will now go here, right? Since we already know that we are going to stop at this place right now, so I'll just go and send this backward and sync it backward. Okay, and now begin to place my column here. So I'll copy again right now and copy my columns from midpoint first, and then go ahead to this place where we're going to stop and place it here, and then try to flush it directly. I will flush it on this place to flush it here. Okay, that's what I'm flushing right now, so that the column can be able to flush at this place, so that else if I extend it out, when it will come out this way as from the right view of this building, you can see that the column will have to go and extend beyond this area, which will not be okay. So that's why I have to flush it to be able to flush with the wall coming downward also. Okay, so right now we will now go here and then begin to paste our columns I will tell you the at least minimum distance to use from column to column as a beginner. I will tell you the minimum distance to use from column to column. So just hold on while we go. And while the lecture is going on, if you have not subscribed to my channel Ekidel, I will say, and if you find this video very useful, I will say you should click on the subscribe button so you don't miss all our coming videos when we'll be performing other kind of design, because in this project we have a 21-story building which we are still working on. We are trying to understand the plan. As you can see it here from a client, we have 20 ones. You can see there we have, this is a 24-story building and this is a 30-story building which we are trying to perform the structural design. You can see it here, we are already performing the GA, as you can see it here, placing of columns and all that. You can see there. So in the next coming days we will be performing this on Ekidel also. This is a live project that came from Vectin 13 country, as you can see it here. So right now, let us go back to our plan right now for what we are doing. Okay, here. Okay, so right now we will now go here and begin to click on our begin to place our columns right now. So I've placed here right now. Column position depends solely on you as a structural engineer. No one will advise you on where to place your columns, but you only use the guiding principle, which I will tell you right here on Ekidel, which is the column distance. So which I'll tell you later when we are checking our distance between column to column. So once you use the guiding principle, all you have to do is to make sure that your columns are hidden inside the wall, because that gives beauty to any structural design, to make sure that your columns are hidden inside the wall, except in most massive buildings that you cannot hide your column inside the wall, that the column must be able to come out. At that point you cannot bring out the column. So this place right now, what I'll do, because of I don't want to place a column here, I'll just change this column orientation right now to be this way. Then let me see what I'll do. I don't want to place a column here, but this is an edge which requires to have a column so that there will not be cracking or there will not be a differential separation between this wall and this wall. Okay, so let me just do go here right now and do this. That will give me here to be plain empty. Okay, I'll do this right now. Okay, and place this here. So when I check on when we check our distance, if this distance is below our standard, we have to place another smaller column at this point here. Okay, so right now this is okay for this, and then we would have to place a column here right now. A column will be here, column will be here. So we will place a column here, and that column will place a column there right now. We'll place a column here. Zoom out and place a column here. Okay, so and that column is coming out on this place, which I'll show you what to do later. Okay, then we go and place. Now we have all done placing, okay, external column right now. So we click on this column to copy this column orientation and copy it from here, and then come over here and place this here. Okay, so right now we are done placing all our external column, as you can see what we have done right now. Now we meant to place our internal columns right now. So we begin to check first our column distances first. Now when you're placing your column in any building, any kind of building, at least as a beginner, who doesn't have enough of experience, I would say you should guide yourself below 6 meters. That your column spacing or the distance from column to column should be less than 6 meters. For now, although I already have 10 years experience, so I can take a column distance of up to 10 meters. I have designed a column distance before of 11 meters in concrete. So that's because of I have experience on that. I know how to maneuver myself when I come to the reinforcement and also when I come to the construction. But the maximum distance you can use for concrete structures is 12 meters, because the length of a reinforcement is 12 meters. So at 12 meters, once you want to exceed 12 meters, you have to change your choice of your material to steel. Else, you have to break that point. You have to break that point by placing a column. I don't know if you understand. And if you're having any confusion, we always have our WhatsApp platform. Check us up on WhatsApp, and we will guide you on how to do that. Okay, so right now since we have checked this column distance from this point to this point, and this gives us four 4.0 as 4.4 as I see it here. So automatically this is okay. No need to place another column here because it is below 6 meters. At least for a beginner, use that rule. Okay, so check this also from here to here, and this gives us 4.1 meters, which is okay. And check from this to this also, this gives us 4.15, which is okay in meters. And then we check from this also, this to this, and this gives us 3.05 meters. That's okay. And then we check from this to this, which gives us 4.2, which is perfectly okay also. Now we will now go ahead now right now and now begin to we check this also. Always check all your column distance from this point to this point, and this gives us 3.65, which is okay. And then we check from this to this look in a bit longer to this, and this gives us 4.6. So you can say that on our eyes here it looks as if it's long to around 6 meters or 7 meters. But since we have checked these dimensions right now and see that this is already below 6 meters, it is okay. Now that you know the rules in placing your columns, now that we have placed all the external columns right now, we have also checked this one, or we have checked this also, which is 2.9, which is also okay. From this column to this column, it's okay. Now that you have known the rules in placing your columns, now we will now enter to check our external columns right now. So check from this distance also, distance is 4.4, so this is okay. And then we'll check now we are done placing our columns right now. Now we will now have to now begin to do what they call paneling. So once you're done placing your columns right now, next thing to do right now is to now begin paneling. And paneling simply means how you want your slabs to run and how you want your beams to be placed. So right now we will now begin paneling right now. And there is a rule in paneling, there is a rule in every design code, and we will be using British Code of Practice, which is BS Code 8110 for the design of this structure. And there is a rule in BS Code for paneling, which I'll tell you as we begin. Okay, so right now, beginning right now, I want to make this place a full concrete beam. So I'll just extend this right now. I'll stretch this out from here. So I'll just click here right now and EX to extend this and extend this. So right now I am using this right now as my beam. So sorry, I'll just remove this right now. So this now becomes our take this back also. So right now we are trying to perform our paneling, which shows how our beams and our slabs are running. So right now I can see that this now becomes our panel. So I'll just come here right now and change this place and call it panel 1, or I'll just use a small acronym and say P1. You can see that. So P1 simply means panel 1, so I'll just call it P1 and then continue. So I have gotten my first panel, knowing that our band range for our design is only based on this area where we're having this magenta color, as you can see it here. So all this place back here now becomes bungalow, although we will still put a preliminary columns of sizes 150 by 150. That is because if you look at the plan, if you look at the elevation right here, you can see that the edges of all the buildings have parapets. And when you have parapets on your edges of building, it's advisable to put column at all the edges having parapets, because parapet loads are being transferred or carried by the column. Also, I always advise you put column. So since this building right now has parapet at this point, as you can see it here, so I'll put columns at the edges of this building. So I'll put the column here, but which is just a minimal column, and also column here, and one at the middle or anyone here, and also one at either two at the mid span around here, to be able to carry the parapet wall that parapet coming to this building. Okay, so right now we will now begin to do our paneling as I've already told you before. So right now, this now becomes our panel 1 right now. I can see it here right now. So also, we will now check on this place. So we want to panel this place also. So I will remove this door symbol right now. I want to form this place as one panel. That's only if the rule that is guided by by BS Code. From BS Code, we'll be able to work on this area. So we will now remove this place right now, and remove this also. Remove this door, because right now when you're placing your paneling, you just remove all the symbols of doors and all that. So remove this door also, and then extend my we're going to extend our remove this, and also remove this and remove this. Enter for the erase, and then I'll stretch this out. Then also this can be, then I'll stretch this out also. I'll just put a stretch by stretching this out right now, and keep this here, and then make this to cover up right now. And I'll go here and copy this and call this one, I'm copying right now, panel 2. So we have gotten our second panel right now. As you can see it here, how we have made this whole panel smaller. Before, we have how many panels? That's before, from the plan we have one panel, sorry, we have one panel, two panel, three panel, small four panel, and this five. But right now you can now see how we have shrinked all those space to just two panels, and then we are trying to build on this area. Now looking at this area right now, for this dining area, which also have a staircase, which an open work staircase, which I will be showing you a software that I used to design for design and detail an open work staircase. Okay, so we will just check on this place right now, which is the first floor. Now coming on the first floor, right, let's see that the first floor have a void on this place, which I think the whole concept is that the master's bedroom, which is the man, will be able to, from the staircase, can see through what is happening directly on this dining area down here. So with that right now, we'll just go ahead and copy this void symbol to, and copy it and choose a base point. Choose a base point and choose from this place, because this building doesn't have a cantilever. As you can see, there's no cantilever on this building, so all the walls flushes equally. So that's why I'm choosing these base points here. Else it is always advisable to choose base points around the staircase, because staircase does not change in all the floors. Okay, so we'll just go and pick this here. We can now see that this is where our void is. So I'll just extend this right now. The reason where I pick that void to check on where our void is here, this with this right now, this tells me that there won't be any slab on this area, because this is a void. So my slab, anything I'm doing about my slab will end directly at this place. So this place now we have to be slabbed. So with that right now, I will remove this right now and call it panel 3. So just this area becomes panel 3. So this area alone right now becomes panel 3. So along this area, let me just move this a bit. So along this area right now becomes panel 3. So that now guides me how I will now perform my staircase. So with this right now, I will form another boundary again for my staircase, because all the staircase area is usually void also. So I'll guide myself right now on from here to here, and to here to here. So this place right now shows how my slab is going to run to, from here again to here. So with this right now, this tells me that whatever I'm doing, there won't be slab around this area. All this place will be designed with staircase. You can see there right now. Staircase will be used to design this area. So where here will be our first landing and second landing. These are first flight, second flight, and third flight. This is an open way staircase, which I'll show you the software that will be used to design and detail this staircase just after our design of this building in Protastructure. Okay, so right now you can now see that this is only place where we are expecting our slab. So this place alone right now is called panel 3. Now you need to ask question right now, how do we suspend this slab area on this place? Because when there is no column on this area and on this area, and that I'll show you when we enter Protastructure for the design of this building, which I'll show you how to suspend this slab, because this is acting like a cantilever slab which have different shapes that you can see there. Because there's no need for you to go and put a column here, else it will be flying on an empty space in the building, which is not always advisable, because someone can go and hit his head at that column during the dark hours. So it's not always good. So with that right now, I'll show you what to do when you have this kind of thing, and I'll show you that in Protastructure. So we have come to the end of this training right now. So what I'll do right now, once you're done with your GA, well, with your column position on your first floor plan, on your ground floor plan, sorry, so it's always advisable to copy it down to the first floor to be able to see if the column matches. So right now, I'll just remove this boundary right now, since we already know that this is our boundary, and also I'll leave that here, and I will now copy my column. So I'll just click on this right now, right click and say copy, select similar, and select all the similar columns as you can see there, and I'll copy right now from base points, from this point, and then I'll move all the columns right now to this place to see. The reason for doing this is to see if the column flushes from wall to wall. Else, we will not know the column that we're going to terminate at the slab and the one that will continue down to the roof. So with this right now, you can now see that all the columns flushes or are hidden inside the walls. So with this right now, it's perfectly okay and it's sound. So to now begin to move this building right now to Protastructure, to now begin our full structural design in Protastructure. Like I said before, when we get there, I'll show you how to suspend this slab on this area. Okay, so right now we have come to the end of this training. Like I said before, I'll drop the cat file of this full building right on this video description, so that you can download that and use it for your personal practice also, because with this cat file you can be able to follow along with me with these design examples and design projects. Okay, so right now you can also see how beautiful all the plants are and everything. Although the length, we're going to carry a minimum, a maximum of just $2 just to be used to support this platform. So if you want to use this cat file, you can just pay that and download that. Else, you can just pick up any other of your plan and then begin to use it. But it's always good to use the same plan that is used for a training, so that you can be able to flow along with the person or your trainee. Okay, so right now we have come to the end of this training, and if you have any question at all, I would say you should drop it at the comment section and we will reply immediately. So you can now see what to do, the first thing to do before you can now begin your building design in Protastructure software. Okay, so thank you so much and God bless you all. And if you find this video very, very useful, I would say you should click on the subscribe button so that you don't miss all our coming videos that we will be coming based on this training and other trainings also. Okay, so thank you so much and God bless you all as we watch out for the next part, which is part two of this structural design, when we are going to move this building to Protastructure and begin our full design. And in there also, I'll show you how to put these columns that are going to carry the parapets in that place also. So thank you so much and God bless you. Have a wonderful day.